Hello everybody, so in this video we will be looking at linked list. So first of all, what is a list? It is just a collection of data. It is just a collection of data. So now our question is, if we have arrays, then why do we need linked list? Why do we need linked list if we already have arrays? So let us suppose for an example, uh, this is our array. We have defined an array of size, let's say 6. So this is our array of size 6, and we have filled the values with 1, 2 and 3, and these 3 are some garbage values. And now at certain point we don't need these values, these 3 values we don't need them, so these 3 block of memory is wasted. This 3 block of memory is wasted. Even if we initialize an array, we need to allocate the memory to that array even if we don't use that, so that there will be a memory wastage of memory. And we can avoid this using a linked list. Let us suppose we have this chunk of memory. This is address 1000, this is 1004, 1008, 12, 16, 20, 24, 28, 32, 36, and let us suppose this is 40. And here we have some value x, 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 and here we have some value x, here also we have some value x. Now we initialize an array of size 4, suppose. Now we need 4 block of memory adjacent to each other to store this array, but as we can see we don't have 4 block together. We have 3 but we don't have 4, and we can't store this array in the memory. So now for a linked list, what we can do, we can store one element here. Suppose we create a linked list of this. We can store one element here, and we can link the address, this address, to the next, and we can store one here, one here, and one here, for example. And in this way we can save up the memory. And if we have an empty linked list, the size will be always be 0. But in case of arrays, we have to always give some size. So now let us just visualize a linked list. As in array we have some structure, as we visualize some structure like this: 0, 1, 2, 3, 4, with some indexing that starts from 0 and some value, suppose x, y, z, a, b. Here will be numbers, suppose 10, 20, 30, 5 and 4. These are the values. Now for a linked list, if I what I will have, suppose this with value something as 20, and it will also have a link to the next address. Suppose it is 1004, so this value is connected to another link whose address is 1004, and it has a value 30, and this has a address of 1000, and suppose this has address of 1000 here. This is 1004 and something like this. Now for an instance, this is connected to, it has a address of 200, so it is connected to a address of 200 which has a value 40, and it is further connected to some value, or in the end it is connected to nothing, that is null. And in the linked list, the first node is termed as the head node. First node is termed as the head node. If you are doing competitive programming, in most of the questions, or if you have ever been on lead code or some of these platform, when you are solving question for interviews or something like that, practicing, you will always be given with the head node. In most of the cases, like in 80 to 90%, you will be given the head node, and you have to then perform the certain operation which is asked in the question. Yeah, so the head gives the complete access, gives us access to the complete list. Now let us just compare our linked list and array. So let us suppose this is our array 0, 1, 2, 3, 4, and this is our linked list, and now this one is pointing to null. I'll use n for null. Okay, and the value are 10, 20, 30, 40 and 50 here. Now In array, we can access any element like this. If this is array arr, so if we want to access the second element number third, that is index number 2, we can use arr of 2 and it will give us value 30. So we are giving it order 1, and these are the time complexity notation: big O, theta and omega and all this. If you have read these, then it is good, but those who are in first year or second year, you will read it in second year. So now for the linked list, if I want to access this element 20, I can't just directly go to 20 because I always will have the access to my head node. I will traverse through the list and go to this. Okay, now suppose we have n values in an array and n lists, n nodes to the list, so we can access it in one time. But if we have to go to the nth node, then the time will be O of n. It will take up O of n time. Now for the memory requirement, as we have discussed above, uh, in array, wastage of memory is possible as there are unused memory locations, unused, and memory is also fixed. We can't increase or decrease the size of our linked list later on, though we can use a vector, but right now we are not talking about the STL, standard template library of C++. And here memory is dynamic. We can change the memory at will by deleting and inserting new elements. Now if we want to access the element, or if we want to insert an element in array at first position, suppose we want to add another element here, then it will take us n time, order of n time, and for the linked list it will be 1. Next is how to create a linked list. That we studied how to do it and all this stuff, what is linked list and some basic idea. Now how do we create it? As I told you, linked list, a node has two parts. One, here we have a data part, and this is the link part. Link part, it will store the address of next node, or it will store the address where it is pointing to. So as you can see, at a certain node we have to store two values, that is a data value, as well we have to store the link value. So for this we can use a class, or we can also use a structure. There is another way, the union, but we will talk about that. So those who have the little bit concept of object oriented programming will know how to use class and structure, but for those who don't, I'll just give you a basic way of writing for a linked list only. What we will do, we will define a class, and here we will have a name. We will start with the keyword class with the name of the class. Suppose our name of the class is list, so we have class list. Now there will be quote. Now what we have in a list, what we will have in the list, we have a data part and we need a link part, and suppose this value is 10 and this is address. So I'll have a int value of data, and I need a link. Okay, so it will be a pointer variable of type list star link. List star link, it is the name of the variable, and we always close the class like this. There will always be a semicolon at the end. So this is the data variable. This is the data variable for our linked list. Data part of node, and this one is the address, the link. It will store the address of the next node. So this is for a class. If you don't know about pointers and all this stuff, don't worry. If you are watching this linked list video, so I am sure that you have already done some pointer and stuff. So now for a structure, how we will define, everything will be the same. What we will do, as we have used a class keyword up there, we will use a struct keyword, struct link, whatever the name you want to give, and give it node or something like that, but make sure the names are self descriptive. Suppose if you are making a class for car categories or stuff, so you can give the name as class car or something like that. Then here we will store a data, same, and a link star next. Okay, let us give his name next, and we will close it same. Now this is we have done. Now how do we create a node? This is how we have created a node. Now how to create a new node? So let me write it again. We have a class of node. Now in our main function we want to create a node. How we will do it? First of all, as the link is a pointer, so we will use the type, that is the class name, node star temp equals to new node. What this will do, it will create a new node here. Okay, and the data part is empty, and this is also empty. It is just an empty node. It is not pointing to null, it is not pointing to anything else or anything like that. Now suppose if we want to insert some data into it, as it has two parts, one is this data part and one is this link part, and we want to point this link to null, suppose end of the list. So how we will first of all insert this data? What we will do, we will take our pointer temp node, the name of the node. We will use the arrow operator. We can also use something like this. First we will dereference it, then we will use a dot operator, then we will use a dot operator, and then now what we will use, as you can see in our struct class, or in our this class also, class of node, we have data, int data. So this temp data equals to 10. Now at this data location we will have a value 10, we will have a value 10, and its link we will do the same thing, temp, and what name we have given, next. So address is pointing to temp, next is pointing to null. Now in the link part there will be null. This is how to add a value and add a link. After that we will see the code too for creating a node. And so I have created a workspace in my code block. Now first of all we need to define a class. So let us just create a class, or we can also create a structure, class of node. I'll insert the value in data and node star next. This is what I have. Now here I'll just insert value at random, so, and then I'll just traverse it, and I'll also show you how you can write a function to insert a value at the end, at the front, or at any position. So first of all, now let me just create a new node. So node star temp equals to new node, node star temp equals to new node. I can just add value here too, or I can do another way. I'll just show you this way some other time. Temp data equals to 3, temp next equals to null, return 0, and let us just print first of all cout temp data, and let us see what do we get. Okay, in node data is a private within context. Okay, we need to set it to public. First of all, these are some SS specifiers. In class it is private by default, and in structure it is public by default. Now let us see. I think we should get a 3. Yeah, so as you can see we got a 3. So this is the basic idea behind the linked list. From the next video, so this is the basic idea behind the linked list. From next video, in the next video we will see how to insert an element at end, and how to delete from the end. Then we will see at nth position and at the beginning, and after that some basic questions from lead code. And after that we will see doubly linked list and circular linked list too. Circular linked list. If you enjoyed the video and got something, do hit the subscribe button. Thank you.